Hello, and welcome back to today's American Flyer trains for the rebuild of an 812 Baldwin, a Type 2 from 1959. I apologize, the train has already been returned to the owner, so all I have right now to offer is some pages from the factory service manual, and then we'll get to some videos later. Heading into 2023, there are things we know and don't know. One of the things we know is American Flyer AC Gilbert collector operators, myself included, understand vintage trains and accessories are definitely finite. As we used to say, they just ain't making any more of those. I'm not real concerned with 2023 and the future because my focus really is with vintage trains. And I also know that the application, and truly believe, and that drives my action, that the application of good and best practices and standards, including procedures and rebuilds and maintenance, not patching with fast, quick, easy steps, contribute to a value-added proposition that will assist in extending these great vintage trains. I recently completed and posted a video chronicling the rebuild of a Baldwin 504 Western Pacific that featured a CAN motor, a solid-state reverse unit, and LED illuminations both in the front and the rear of the locomotive. I believe it is a possible that 504 was a possible 812 that had been modified. While not entirely vintage and some components may be transitioned from an 812, the rebuild itself and the train's performance was very satisfactory. The focus today in this video is the recently completed end-to-end rebuild of a vintage 812 Type 2 from 1959. My methodology, as always, did not focus on things like why or where or when, nor did it focus on local or spot repairs, simple, easy ways, tricks, just improvements, guessing, well, can we do this? Believing that nothing easy and simple is probably or might not return long-term satisfactory results. And I also believe that a process-driven holistic approach, which I use to return each component to like new factory specifications, impacted the performance of this train in response, putting this train in a baseline foundational condition that I believe the owner really can leverage as a benchmark moving forward for maybe another 50 years with standard preventative maintenance. Again, I repeated that I demonstrated a repeatable trilogy of people, process, and technology involving the right people, being collaborative, process, methodically working through something, and technology such as the tools that this framework, when coupled with discovering task and then assigning priority, timeline, and resources, really pay dividends. And I even point back to Mr. Barker's book, his Gilbert American Flyer S-Gauge Repair and Operating Guide, the 4th edition, which is the one I'm currently using. He even mentions in the Baldwin section, and I quote, a systematic approach to restoring the Baldwin, close quote. And that's what I believe he did as well. Over time, and bad on me, I had formed some unsupported images and perceptions regarding Baldwin parts and components and workmanship. And granted, they're different. Once you take one apart, you're going to see some differences that maybe you didn't expect. There were some that I didn't expect, including things like plastic parts, where we used to see things made with metal components. I'd also heard they were hard to work on and difficult to disassemble and challenging to reassemble. But these two rebuilds of the 504 and the 812 changed my opinion by 180 degrees. Now, all of my opinions about these Baldwins were not negative, don't get me wrong. There were some good things I thought came out of this. For example, the modularity of these trains and the accessibility. For example, you can work on either of these trucks without ever removing the body. Just flip it over in your cradle, and by removing these assemblies right here, the side frame assemblies, you gain access to a lot of stuff from this point down and this point down, including gears, worm gears, bearings, bushings, the wheels, the axles, and the wheels and axles come out so easily that you can, for example, change the wheels on them very, very easily. I actually completed everything from this point down prior to even flipping it over and even thinking about looking at the motor or even thinking about removing the shell. So in that respect, I liked it because I liked that uh, bottom-up logic of doing the small pieces first and then reassembling the most critical last and then expecting performance after that. So that worked well. I thought that, as I alluded to, everything was really accessible. Once the body's removed, the motor is easily accessible, as well as the reverse unit. And this was just a two-position reverse unit. And everything down here was very accessible. Gears, axles, wheels, everything. So that was a surprise, a very pleasant surprise regarding these. I also heard that Baldwins operate hot and are noisy. And yeah, I felt a little heat when I ran this one. And definitely, I don't disagree with Mr. Barker or anybody. They are noisy. They have that same kind of grinding sound, kind of like some of the hand cars. I did notice that upon lubrication and reassembly, I thought some of the noise was reduced. Not so much when the locomotive ran solo, but when it pulled a consist, a little bit more power was applied, and maybe put more stress on the gears and the motor. And maybe it was just the overshadowing of the overshadowing of the noise of the motor by the clickety-clack of the wheels in the consist. I don't know. But for noise mitigation, there are other things I think we can do. Now keep in mind, I don't disagree with what Mr. Barker said. He believed and pointed out in his book, and I have no reason to doubt it, especially somebody with his expertise and experience, that a lot of the heat, if not all of it, the additional heat, came from the amount of sparking that occurs on the commutator and the armature's inability to dispense that heat was one of the focus points of the heat generation by these locomotives. But I also believe that for hot or heat generation, we might be able to identify some possible points of friction and drag. Those are two of my very critical focuses on any of these trains, including the consist, the coaches and the boxcars and everything, how much friction and drag they create. We might be able to point out some friction and drag points on this motor and attempt through cleaning and lubrication to reduce both of those. Now, let me just point out one component, and that's right here. And what we're looking at, and I apologize for the picture that's in the factory service manual, it's not as good as the real thing. This is the armature right here. And notice this long section of armature right here, maybe 3/4 of an inch long, extends through a solid metal component. And that solid metal component is that right there, and that is the bearing and the mount assembly. That's a long way for that armature shaft to extend through that device right there, that component, with little ways to dispense heat. It fits, it doesn't fit tight, of course. It's got to have good rotation and freedom of movement, but that's a small space. And what I did during the rebuild was go to a lot of effort to lubricate, clean and lubricate that shaft on both ends from the top down through an oil wick that sits on top of the bearing and mount assembly, and apply gear lube, not a low viscosity oil, in that area. I don't know what it'll do over time. Maybe it'll help. But one of the things I want to do moving forward is return to one of the tests that I used to do. And that is use the factory service manual specifications. Now, where I find those specifications are on the cover page of the factory service manual. These give the specifications for the amp draw of expectation. It does not give temperature. That's just something you're going to have to measure before and after, before a rebuild and after a rebuild, or after a rebuild, and then compare that to other diesel motors. So here are the specifications. 12 volts, 160 inches of oval. That's going to be 2 180-degree turns and 4 pieces of straight track. Let the diesel pull 4 cars at a minimum of 9 RPMs on this loop. So you're going to have to watch your wall clock time, get the train moving at approximately exactly at 9 RPMs within 1 minute, 9 trips around the loop in 1 minute. And then check your amp meter to see if it's drawing 1.8 amps or less. And that's the way I did it. Then, after stopping the test, after having measured the amps, and I find a way to measure the amps, the best way is to film it. Put the camera on the amp meter. And then immediately after it stops, turn it over and use your surface thermometer to read the heat within the motor as closely as you possibly can, shooting the beam from the surface thermometer right on the motor. Now, again, you might have to, if you didn't do the before and after test, that is before rebuild and after rebuild, you may just have to do comparisons with other diesels. But that's what I would like to do with this one, to see if that heat is really excessive. Thanks again for your time. What you're going to see following either in this video or the next one is going to be a slide presentation with labeling that shows the steps, some of the steps in the rebuild, and then, of course, the railhead test. Thanks again for watching Dave's American Flyer Trains.